In this video, you will learn how to find the number of combinations of n objects taken r at a time, and when there are multiple events, you will learn when you should multiply and when you should add the combinations. So what is a combination? A combination is the result of doing things in different orders, as is a permutation, but still emerging with the same result. What that means is that order is not important in a combination. And so let's look at an example where this is a combination. If you wanted to form a committee of 3 students, maybe you had 5 possible students: Kermit, Animal, Gonzo, Miss Piggy, and Bunsen. We'll choose students at random to give everybody a fair chance of getting on the committee, assuming that everybody is qualified. So the first student could be selected in, well, again, we have 5 students, so 5 different ways. The second student could be selected in, we've already chosen one of the 5, so now there's only 4 different ways. And the third student we could only choose in 3 different ways, because again, by the time I'm selecting the third, I've already selected 2 of my 5. So following our basic counting principle, we have 5 times 4 times 3, which is 60 different ways to choose 3 students from 5. Now, here's something to consider. Does it really matter if you pick Kermit, Gonzo, and then Animal, or Animal, Gonzo, and then Kermit for the committee? Even though they were picked in different orders, they still form the same group. So, let's look at all the different possible orders of picking Kermit, Gonzo, and Animal. I'm going to use K for Kermit, G for Gonzo, and A for Animal. When I'm trying to figure out the exact orders, I want to do this in an organized manner. So we'll do the different orders if I pick Kermit first. I could either pick Kermit, Gonzo, Animal, or I could pick Kermit first, and then Animal, and then Gonzo. If we picked Gonzo first, maybe we do Kermit, Animal. If I pick Gonzo first, maybe I did Animal, Kermit. And if I pick Animal first, maybe I do Kermit, Gonzo. But then maybe Animals first and I did Gonzo and Kermit. There are 6 different ways that we can select these same 3 people. And so that means from the 60 ways we had originally, we need to divide out all of these repeats, these 6 different same groupings that we got. Now, something that's interesting is that 6 is actually the same as 3 factorial. 3 times 2 times 1. And so what that means is if you're trying to do a combination where the order doesn't matter, you want to divide by the number of repeats, which will always be the number of items you're choosing, factorial. So now let's look at another example. In a trifecta, you have to pick 3 finishers of a racehorse in the correct order. So if there's 10 horses running, how many different trifecta tickets are there? Now when I'm doing a probability question, the first thing I want to ask myself is order important? In this first problem, order is important because they said for it to be a trifecta, you have to have the correct order. If the order is important, then you have a permutation. And so here I have 10 horses and I need to pick 3 finishers, first, second, and third. And so if I do 10p3, that would give me 720 with my calculator. So in my calculator, I need to enter the number of objects, go to Math, scroll over to Probability, and number 2 is for permutation, NPR. And again, I needed 3. Calculate 720 for me. You can also do it using our basic counting principle. There are 3 places we're choosing: first place, second place, and third place. When you're choosing first place, there are 10 different horses that could get first. But when you're choosing second place, one of the horses has already been used for first. So now there's only 9 left. When you're choosing third, there's only 8. If you multiply 10 times 9 times 8, you also get 720. Now, in a trifecta box, you can pick the 3 finishers in any order. What that means is order is not important. Whenever order is not important, you're going to do a combination. And so if I have 10 horses and I'm doing a combination of 3, we can calculate that on our calculator pretty much the same way. I'm again going to enter the number of objects, so 10 horses, go to Math, scroll over to Probability, and you'll notice the third option is NCR. That's for combinations. Press Enter, and then again the number that you're going to be choosing for this combination. And that, if you notice, is only 120. Now what's interesting is we talked about how above you basically would just take your permutation and divide by the number of repeats. Well, here, since there are going to be 3 finishers, 3 places, we would want to divide by 3 factorial, so by 6. If you took 720 and divided by 6, you get our 120. So if I again remind you, in a permutation, you are going to do n factorial divided by n minus r factorial if you calculate it by hand. Well, since we now need to divide by the number of objects, r factorial, for a combination, it's n factorial divided by r factorial times the n minus r. Now another thing I'd like to talk about is multiple events. When you're finding the number of both ways for events A and B, so you want both events to occur, you need to multiply. But if you want the number of ways that event A or B can occur, you're going to add. So the key thing being the and or the or. We'll use that in just a minute. Right now, let's practice calculating different combinations. So again here, in A, I would just do 8, the math button, scroll over to probability, and the third one is NCR, 3, and that gives me my answer. Now by hand, what that means we're doing is 8 factorial divided by 3 factorial times 8 minus 3 factorial. That would be 8 factorial over 3 factorial, and 8 minus 3 is 5 factorial. Now remember, 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. And the 5 factorial is 5, 4, 3, 2, 1. So all of those cancel out. And then your 3 factorial will also be a 3, 2, and a 1. So all you really have to calculate is 8 times 7 times 6 divided by 3 times 2 times 1. Of course, we now have our calculator which will actually do all of that for us. And so it's going to be much, much quicker to just use your calculator. So for instance on B, to just use my calculator, I would just do the 10, math, go over to probability, number 3, 6, since it was NCR, and N is 10, 6 objects are, and enter, and I get 210. Please now pause the videos and practice calculating letters C and D. For letter C, you should have gotten 21, and for D, 2002. Let's now look at this in terms of a word problem. In example 2, we're told that a standard deck of 52 playing cards has 5 suits with 13 different cards in each suit. As a reminder, you will on tests and quizzes get a deck of card and dice sheet that looks like this. This is also in your packet, which has all the different cards in a deck of cards listed. I also told you there are 4 suits, 13 cards in each suit, 26 per color, so 26 red, 26 black, what a 4 of a kind means, and how many face cards there are. You'll also have some problems that will look at tossing 2 die, and so those possibilities are also given here for you to use. Now, in question A, we said if the order of the cards of dealt is not important. Again, that is key because the idea that the order is not important is telling me that I need to do a combination here. Doesn't matter if I choose an ace and then a king. I need to know that I have an ace and a king. And so because this is going to be a combination, I'm going to be doing NCR. We want to know how many different 5-card hands there are. Well, again, N is going to be the total number of cards, and R is going to be the number of cards we're using. And so again, there's 52 cards in a deck, and I want a 5-card hand, so I'm choosing 5. And so on my calculator, 52, math, probability, NCR, 5 gives us 2,598,960. Now in part B, we said in how many 5-card hands are all 5 cards the same color? Now there's actually 2 things happening here. In event A, you are going to be choosing a color. So again, that's either the red or the black. And so I have 2 colors, I need to choose one. And event B, I need to choose 5 cards for our 5-card hand. Now keep in mind, we've already chosen a color, so we're down to only 26 cards that are either red or are black. So when I'm choosing my 5 cards, I only have 26 cards to choose from, and I need to choose 5. And because I need both events to happen, we need to multiply these 2 combinations. So the way that I'm going to calculate this is by calculating each event individually and then multiplying those values. So 2C1 is going to be 2. And 26, choose 5, is going to be 65,780. So if I multiply 2 and 65,780, I get 131,560. So notice this was a multiple event. We need to multiply because of the and also keep in mind you chose each event's combination individually. So let's look at some more multiple events. So in example 3, it says that William Shakespeare wrote 38 plays that can be divided into 3 genres. There's 18 comedies, 10 histories, and 10 tragedies. In part A, we want to know how many different sets of 2 comedies and 1 tragedy can you read. Again, the first question you want to ask yourself is order important? Here, it just said different sets of reading 2 comedies and 1 tragedy. It didn't specify you had to read the 2 comedies and then the tragedy, or vice versa. And so that means order is not important. If order is not important, we're going to do a combination. Then you have to look at your different events. It says exactly, meaning we need 2 comedies and a tragedy. So event A would be choosing the 2 comedies. And if we need exactly, that means and event B, which is the 1 tragedy. So for the 2 comedies, there were 18 comedies. I need 2 of them. For the 1 tragedy, there was 10 tragedy. I need 1. And means I need both events to happen, so I'm going to multiply. So like the problem before, if we calculate the 18, choose 2, I get 153, and the 10, choose 1, gives me 10, and so 153 times 10 is 1,530 different sets of exactly 2 comedies and 1 tragedy. Now when we're looking at most, that means you could read 0, 1, 2, or 3 different plays. So if you're going to read 0 plays, we need to account for that. We need to count for 1, for 2, for 3. So we actually have 4 different events going on here. So let's say event A is you read 0. Or event B would be that you read 1. Or maybe event C happens where you read 2. Or event D where you read 3. For event A, I have 38 plays. I'd be choosing 0. Now, or means only one of these 4 events will happen. So I need to add to that event B. There's 38 plays. Maybe I would read 1. Add to that event C. 38 plays, read 2. Add to that event D. 38 plays, read 3. If we calculate these, for event A, I have a value of 1, plus event B, I have a value of 38, plus event C would give me 703, and event D would be 8,436. If I add all those up, I have 9,178 different ways I could read at most 3 plays. Again, what you want to keep in mind is that for event A, I was reading 0, and I took that value. Event B, I was reading 1, and so then I had that value. For event C, I was reading 2, and that gave me this value. And then you also have event D, where I was reading 3, and gave me that value. It takes all 4 values, all 4 events added together, addition because it is OR, to get your end number of ways. Please now pause the video and complete letter C. In example C, because I needed exactly 3 tragedies and 2 histories, and means I need both events to happen, so we had to multiply. And so event A was the 3 tragedies, and from the 10 tragedies I was told there was, if I chose 3 of them, I could do that 120 different ways. For event B, I needed the histories. So from the 10 histories I was told there was, I need 2 of them. You can choose that 45 ways. And so then if you multiply 120 by 45, you get 5,400 different ways to read exactly 3 tragedies and 2 histories. Let's now look at example 4. In example 4, You have to tell if order is important or not. Should you do a permutation or should you do a combination? Please pause the video and decide if A should be a permutation, meaning the order is going to be important, or if A should be a combination, meaning the order is not important. Because in A, order is important, we're going to do a permutation. So, N is, remember, the total number there are, and so there are going to be 8 questions to choose from. I need to choose 5 of those 8. And so 8p5, if we do that on our calculator, gives us 6,720 different 5-question tests. Please now pause the video and decide if B should be a permutation, meaning order is important, or a combination, meaning order is not important. Here, order is not important. They even said to do a combination. So again, from the 8 questions we have to choose from, I need 5 in any order, and so 8 choose 5, dividing out the 5 factorial, the 5 repeats from our example A, gives me only 56 different 5-question tests. At this point, please pause the video and complete example A. For example A, you wanted to form a committee, and so therefore the order was not important, and we wanted to do a combination. So from the 15 teachers, I needed 4. That calculated out to 1,365 different committees you could form from 15 teachers of 4 teachers. Please now pause the video and do example B. In B again, order was not important. It's going to be the same pizza where you put cheese, pepperoni, and then sausage, or sausage, pepperoni, then cheese. So from the 17 toppings, I needed to choose 3, and that calculates to 680 different pizzas. Let's now look at the examples on the next page. In example 6A, it says Pizza Hut offers 8 meat and 9 veggie toppings. How many 3-topping pizzas can be made using 2 meat and 1 veggie? This is a 2-event situation because you have both meat toppings and veggie toppings. Just because you choose a particular meat topping does not have anything to do with the 9 veggie. So again, before I actually start the problem, I want to see, is order important? And no, order is not important because it's still going to be the same pizza no matter what order I choose them in. So now let's look at our 2 events. For event A, we need to choose 2 meat toppings. And for event B, we need veggie toppings. So from the meat, there are 8 different meats. I need to choose 2. And means we want both events to happen. I need to choose meat and veggie, so we'll multiply. Then there were 9 veggies. I need to choose 1. So if I now calculate 8C2, that's 28. 9C1 is 9. And 28 times 9 gives me 252 different pizzas. Please now pause the video and complete example B of 6. In example B, I had 3 different events. I was choosing 2 green marbles, 1 yellow marble, and 4 blue marbles. So for event A, I needed to choose 2 green from 4. In B, I needed 1 yellow from 3. And in C, I needed 4 blue from 6. I did a combination because it didn't matter the order I chose them in. And so when I calculated each combination, 6 times 3 times 15, since I need all events to happen, is 270. Please now pause the video and complete all of example 7. When you are done, check your answers with the video. In this example, the key thing to remember is that you are always trying to get 4 coins. So in A, since you just need those 4 coins to be dimes, we take the total number of dimes and choose 4. That calculates to 15. B is where it starts to get tricky. If you want at most 3/4, you could choose 0, you could choose 1, you could choose 2, or you could choose 3 where you have quarters. Each event is separate and only one of them will happen. Because only one of them will happen and it's OR, that is why I'm adding the different combinations. For event 1, where I'm choosing 0/4, that means from the 4/4 I'm choosing 0, and from the 11 other coins I need to choose 4 then, and that calculates to 330. In event B, I need to choose 1/4 from the 4. That means to still get 4 coins, I need to choose 3 from the remaining 11, and that calculates to 660. Then for event C, I need to choose 2 from the 4/4, and that means to get again 4 coins, I need to choose 2 from the remaining 11. And lastly, event D, I need 3/4 from the 4. That means I need to choose 1 from the 11. And if I add all of those up, I get 1,364. When it's exactly, notice that 2 nickels and 2 dimes add together to give me 4 coins. And because I need both the 2 nickels and the 2 dimes, that is again why I'm multiplying. From the 5 nickels, I needed 2, and from the 6 dimes, I needed 2. So 10 times 15 is 150. For D, again, exactly 2 nickels, the 5C2, and 2/4. There was only 4/4 to choose 2 from, so I could only get 6. 10 times 6 is 60. Again, it's exactly, so I need both events to happen. That's why I'm multiplying. Now E, we get back into the at least, at most. If I have at least 3/4, I could have 3/4 or 4. Not more than that, because remember, we're only choosing 4 coins each time. So if I were to choose 3/4, then from the 4/4 I need 3, and from the other 11 coins I only need 1 to get a value of 44. And then if I chose 4/4, from 4 I need 4, and from the other 11 I would need 0. It gives me a value of 1. And then again, because this is OR, either I choose 3 or 4. Both events will not happen, and so I add those combinations to get 45. F follows similar way. You should have gotten 555. And G follows similar to C and D, and you get 180. Please now complete tonight's homework assignment and then do the review assignment for day 4.